Alrighty, welcome back. We're going to be talking about converse, inverse, and contrapositive here in our logic unit, section 15F from the book. As you can see, we are looking at the implicative statement here, P, if P, then Q. P leads to Q. We learned about that last lesson. Now, of course, we can change the order and add some negation, which gives us some different terms here. We're going to start with converse and inverse. Okay, and we'll get to contrapositive in a minute. Converse and inverse, we switch it up a little bit. With converse, Q leads to P. Now, the way that I have students remember this, the word converse they may know as the brand of a shoe, right? So what you do is you picture somebody wearing Converse shoes jumping up, switching their left and their right, and landing with their legs crossed, right? So they switch the order. This is now on the other side. This is now on the other side. So converse is when the order is switched, like you crossing your legs and switching the order of your Converse shoes. Okay? Inverse, on the other hand, is the word for negation. The inverse of 7 is -7. So the inverse of an implicative statement is when you negate each one of these. So this is, if not P, then not Q. Alright? The contrapositive is easy, because it's the long, weird, funny name, and it's both. You both switch the order and you negate both. Okay? So now we're going to take a look at converse and inverse in terms of a truth table, right? So we did this before, last lesson. You've done the not before. You should be able to figure out this whole truth table. So I want you to pause the video, see if you can fill this whole truth table in, and then push play again and you'll check your work. Okay, so you have given this whole thing a shot. Let's see what you can do. Actually, I'm going to quickly fill this in. Okay, so I filled in most of these columns. These should be pretty obvious. The implication we learned last time, not P, not Q. Pretty good. Actually, this isn't the implication. Excuse me. This is the converse. If Q, then P. Notice that I did this wrong here. I did this wrong. Because I was doing it as if it was an implication. So, let's take a look here. This is completely incorrect. Now, we're starting with Q going to P. If this is true, then this is true. So that's true. This is false. So this is true. So we'll give it the benefit of the doubt. True. This is true, but then it leads to a false. That's the only time it's false. And then if this is false, this is also false. We give it the benefit of the doubt, and it's true. Okay? This column here, if not P, then not Q. If this, then this. See, that's the reason we have these columns, so then you can just look at these two columns to feed this. Remember that an implication is only untrue if the first thing is true and the second thing is false. So, this is the only one that's going to be false, right? The rest of them are going to be true. Okay? So that's comparing the converse and the inverse. What do you know? What do you notice about the converse and the inverse? What do you notice about the converse here and the inverse here? Do you see it? Do you see that the converse and the inverse of a statement are, in fact, logically equivalent? Okay? So if you do the truth table, you notice that the converse and inverse of any statement are logically equivalent. Kind of cool, huh? So we're going to do the same thing, and we're going to compare an implicative statement with its contrapositive. I'll bet you can't guess what's going to happen. Go ahead and pause the video and fill this in, this whole thing in. Alrighty, so I filled it in here. Did you notice? I'll bet you did. Did you notice that comparing an implicative statement and its contrapositive, here's the implicative statement, here's the contrapositive, what do you see? Do you see that they only have a false in the second row there? They are in fact logically equivalent. So, again, an implicative statement and its contrapositive are logically equivalent. I hope you learn a thing or two, and we'll see you next time. Toodles.